Okay, so what we have practiced last time, we have practiced the equation of motions, and we have mentioned all those equation of motions are from straight line graph. So those equation of motions are from straight line graph. And what we practiced, we have practiced there are 5 equations, and in each questions we are given 4 variable, and in every question there will be one such thing which is not discussed. In every question of kinematics there is must one such thing which is not discussed, and every equation out of the 5 which we have written has one such variable which is not discussed. So what we did that we use it and we apply it, and we get to know that, okay, like this question, we have S not discussed, but we have U, V, A, and T. U, V, A are given as we throw an object upward. Got it? So what was not discussed in the whole statement? There was no discussion about X. They have neither given us X, they have nor asked us to find it. Got it? In this statement, there is no discussion of displacement. Got it? So that's a hint that which equation shall we use? We shall use an equation in which there is actually no displacement. So if you check the set of the equations, can you identify which equation? Because I'm just discussing it because a little bit of Tanya, because she has not practiced this question with me. So if we look at the equations, which equation do not have S in it? It was the first one. So what we will do, we'll use the first equation. So that's the trick, how to get to know which equation must be used. Got it? So we will use the first equation, that is V is equal to U plus AT. So we have everything. We put the values, and or you can rearrange it for T first. So you will write it as V minus U equals to AT. So A is being multiplied, goes to the other side and divided. So V minus U over A is equal to T. Is that right? Is it okay, Tanya?
Yes.
So you just put the values and you will get the answer. But in the same question, if instead of the time, like I put the values, we will get 20 is the final velocity minus 50 is the initial velocity. Our minus, I'm using it for the moment minus 10, so that we have not to use the calculator. So what we will get? We will easily get minus 30 our minus 10, which is 3. So that's the time, 3 seconds. Got it? But if in the same question someone asked us to find, instead of at what instant, they asked at what displacement. For the second part of this question, they asked us at what displacement. Now if you look at the question is modified. Instead of no discussion of the displacement, this data has a discussion of displacement but no discussion of time. So what we have this time for this new question, what data we have? We have initial velocity as 50, final velocity as 20, acceleration due to gravity minus 10, because why? Initial velocity is upward, final velocity is upward, acceleration is downward. So if something, we have written it clearly, if something is in the opposite direction to that of the that of the initial velocity, that's the point which we have clearly written here. If something is in the opposite direction to that of initial velocity, we consider it negative. If it's in the same direction, got it? Then we consider it positive. If it's opposite, then negative. So for the moment, it's in the opposite direction. Acceleration due to gravity is downward. Initial velocity was upward. So that's why we choose it negative. And this time we have not to find the time, we have to find the displacement. So for this red data, which variable is not discussed? U, V, A are given. S we need to find. So there is no discussion of, for this question, there is no discussion of time. Time for this part is neither given nor asked. Is it clear? That time is not the discussion in this part. Tanya, is it clear? In this part, there is no discussion of time.
Yes.
So we will go to the set of equation and check which equation is not having any time in it. So that's the last one. So we can clearly, easily pick this way that which equation to be used. Okay. So we use this equation and we will get the like displacement. So that equation is, for the red data, the equation is v square is equal to u square plus 2as. So we put the data or rearrange it for s. So s will be equal to v square minus u square over 2a. Got it? So when we put the values, we get 20 square minus 50 square over minus 2 times minus 10. So if we solve this thing, we get 105. Got it? So the thing which I want to discuss again, the second side is exactly the same data, but only difference is this is moving downward. So when we write the data, initial velocity is 50. Read the statement: an object thrown vertically upward with a speed of 50. At what instant of time it will be moving downward? Only difference is in the previous it was moving upward. Now it's moving downward with a speed of 20 meter per second. So initial velocity is upward with a 50 value. Final velocity is 20, but why we wrote it 20? Negative 20 because it's downward. So as it is downward, so is it in the same direction as that of the initial velocity or opposite direction? Tanya, is it in the same direction or in opposite direction? Is it in the same direction of initial velocity or is it in the opposite direction?
The same direction.
Oh, look, initial velocity, in what direction you throw the object? Read this question.
Yes, vertically.
We are throwing it up or down?
Oh, downward. Downward.
No, listen carefully. In what
No,
direction
first
we are?
we throw it vertically, and then
Yeah, listen.
upward,
Yes. So my question is
and now
initially,
downward.
yes. So final velocity is in the same direction or in opposite direction? Initially it was up,
Opposite
finally it's
direction.
down. So it's in
Down.
opposite direction. That's why this 20 is, although the question not tells you that it's negative, got it? But the rule which we need to use is that anything which is in the opposite direction to that of initial velocity will be negative. Got it? So the other thing is the same. Acceleration is also downward. So that's why it's also negative. Got it? So anything which is in the opposite direction to that of initial velocity will be considered negative. In this case, both were upward. Initial velocity was upward. Final velocity was upward. That's why they were positive. Got it? Why this is negative? Because it's in the opposite direction to that of initial velocity. Is it clear? Which one to choose
Yes.
positive, which one to choose negative? That's good. Okay, after this, what we need to discuss is, just wait a moment. Let me check. Okay, I will just use a new board. We have to consider a concept of relative velocity. or relative speed? So any one of you have an idea about relative speed or relative velocity? Do you have an idea about relative speed or relative velocity? Uh-oh, no reply from you. Do you have an idea about relative speed or relative velocity?
Like how the speed of an object might look like to another viewer.
Yes, very good. Like if you are sitting in a car and the passenger right next to you sitting in the same car, so what's your speed with respect to the other person? You are not moving, you are sitting by side, isn't it? Can you hear me?
Yes.
Okay, just wait on, please. So look at this. I draw an object here. Say that each box, I do write it first. Each box on this figure is representing 5 meters, or say 2 meters. Each box on this figure is representing 2 meters. So I write it. Okay. Okay. So each box is 2 meter on x-axis. So I show you the position of an object like after 1 second. So it was here. After 1 second, it's here. After 2 seconds, it's here. After 3 seconds, it's here. So what is its speed? Who will say? At 0 second, it was here. I just write it again. Just don't. At 0 second, it was here. At 1 second, it was here. And like that. At 2 second, it's here. And at 3 second, it's here. So what's the speed of this blue object? Let's see who give the answer.
Six meters per second.
That's right, Tanya. What about you, Fatma? What's the speed?
2.6 meters per second.
Why 2.6? It's just 6. How? You can pick anything. For if someone just say the average speed or speed, just look at the total distance it has covered. So from here to here in 3 seconds, how much distance it has covered? Can you tell me how much distance it has covered in all 6 seconds? Sorry, 3 seconds.
8 meters.
Each box is 2, so that's 2, 4, 6, 8, 10, 12, like that. So in like how many boxes are these? How many boxes are there?
18.
Okay, you give me the distance. Boxes were 9, so the distance is 18 meters, is right? So the blue object moved from that point to that point, the 18-meter distance, in how much time? Fatma, how much is the time?
3 seconds.
That's very good. It is 3 seconds. So if you just use the simplest formula for the speed, what you will get?
6 meters per second.
So got it? How it's 6 meters per second?
Yes.
That's good. Now, there is another object. Both of you make the messages direct to me and write your answer in the chat window rather than saying there is another object. I say that it's a green object and it moves like this. Just wait on. It moves like this. So what's the speed? Every 1 second I have shown its position. I just write the position again. So that's 0 second. That's 1 second. That's 2 second. That's 3 second. That's 4 second. That's 5 second. So what's the speed? Still each box is 2 meters. So what's the speed of this green object? Write in the chat. Both of you write the answer in the chat. That's right, Tanya. Sorry. That's right, Fatma. Very good. Now, if I say, what is the difference in their position? Their position is actually, these lines are telling you the position. I just mark it. These red lines, which I'm going to draw, is actually marking their position. Just a second. Okay. So that's their starting position at 0 meters, right? That's their starting position at, this red line is showing 0 meters, right? So they were at the same position. How much is their difference in their position after 3 seconds? After 3 seconds, how much is the difference in their position? That's 1 second. That's 2 seconds. How much is the separation between them after 3 seconds? I'm simply asking separation yet. After 3 seconds, how much is the separation?
Well,
You can
I'm
write.
confused.
Okay,
How
no
to.
problem. No problem. Just think as the values. I said in the beginning they were at 0 meters. So this is 0 meter. This was 6 meter. This was 12 meter. This was 18 meter. Look at the green object. It was at 0 meter start. Then it is at 4 meter. Then it is at 6 meter. then it is at 8 meters. So now look at the position. Where is the green object? At 8 meter. Where is the oh, just wait a moment. Have I done something wrong? Have I done something wrong? 6, 12, 18, 4, 6, 8. Oh, my mistake. It's why I write it like that. 4, 8, and 12. My mistake. Just wait a moment. 4, 8, and 12. Their positions, each box is 2 meters. Got it? So it's 4, 8, and 12. So it's 8 meter, it's 12 meters. For the second line in 3 seconds, yeah, has traveled 4. The green object has traveled in first 1 second 4 meter, in the second 1 second 8 meters, and in the third second 12 meters.
There
So
in the second line, in 3 seconds it has traveled 4 meters. Because when you multiply 6 with 12, you get
no,
6 with 2, you get 12.
yes, it's
12
now I
divided by
corrected it.
3.
Now I have corrected it. So it's 12 meters. Got it?
No, it's not.
What's
Oh, okay, I get it. I understand.
earlier it was wrong. Now it's right. So now look
Yeah.
at the position of the green. Green is at 12 meter after 3 seconds. Where is the blue? At 18. So like Fatma has written. So what's the Tanya, give your final answer. What's the difference between the two? What's the difference between the two? 12 and 18. That's right. So 6 meter. Red moves 6 meters ahead. Red move 6 meter ahead of green. In how much time? In 3 seconds. So what's the relative speed of the red? So 6 meter over 3 seconds. So red is moving 2 meter ahead every second. And you can see that every 1 second, red is moving 1 box ahead. So that's one. Here the 2, and here the 3 boxes. Got it? So that's the relative speed. But there's an easier way to find the relative speed. We have the speed of the red. Sorry, I use the blue and the green. We have the speed of the blue. What was the speed of the blue? It was 6 meter per second. And what was the speed of the green? It was 4 meter per second. So the relative speed of the blue with respect to the speed of the blue with respect to green is VB minus VG. So that's what you get. 6 minus 4 as 2 meter per second. Got it? So blue is moving 2 meter per second ahead of the green. So this kind of comparison where you subtract one speed from the other to get the comparison is called relative speed. Is it clear?
Yes.
So how we find the relative speed? Relative speed is only you need to take care which object, which speed minus from which one. So relative speed is V1 minus V2. You can find both. You can find this relative speed of B with respect to green. If the I write it here, I write the speed. I'm not drawing the picture because that picture was just for explanation. So we have the velocity of a blue thing toward the right, and that's positive 6 meter per second. And we have the velocity of the green that was also toward the right, but it was 4 meter per second. So we have two answers. What we have worked out relative speed. I do write the full sentence because it does make a difference. Just a moment. So what I have worked out is relative speed of, just don't, why it's not. So it was okay, relative speed of blue with respect to green. So in that case, you will do VB minus VG. Just a second, please. What we get is relative speed of the B and just don't minus relative speed of G. Oh, sorry, speed of B minus the speed of G. Just a second. So that's what we did. Is that right? So when we put the values, we get our answer as, oh, okay, what's wrong with it? Just a second, please. We get our answer as what we have practiced, 6 plus 6 minus plus 4, that is actually equal to plus 2. Is that right? But remember, we can also work out it the other way around. We can work out the relative speed of the green with respect to blue. The relative speed of G with respect to B. Then we have to do this thing reverse. Got it? Then we have to do VG minus VB. Got it? Then we have to do this. So what we will get? We will get plus 4 minus plus 6. So what will be the answer? The answer is -2. Why? Because if we look at that object, for the green, blue is moving forward in the positive direction. But for the blue, isn't green moving lagging behind? Can you see it? The green is lagging behind in the backward direction. So that's why -2. With what speed you crosses a car forward, with the same speed the other car lags backward. So for that car you are moving forward, so your speed is positive, and for your car, the other car which is lagging behind is negative speed. Got it? So you can get both speed, relative speed of one object. For one object the one is moving ahead, and for the other the first one is moving back. Got it? Is that clear? So you can work out the relative speed both ways, depend with respect to which you want to find. Is it clear? And positive and negative just tells you the direction. So we have considered the forward direction as positive. That's why this blue is moving ahead with a +2 speed, and the green is moving back with a -2 speed. So negative and positive are just representing the directions. Is it clear?
Yes.
Okay, that's good. So just give me a moment. After the relative speed thing, just a moment. Okay. Okay, the next thing which we have to start is force. But before I start the force, I just want to confirm something. So just give me a moment. Or instead of practicing force, what I'm going to do, we are going to practice some kinematics question. Is that okay? So that you get a good
Yes.
use to those questions. So just give me a second. Okay, try to write your answer in the chat. We are going to practice some questions. These. So question 2, write your answer in the chat.
Okay. So, yesterday we discussed, like last time we discussed that in a graph we should be very clear about y-axis and x-axis. So, both of you, just tell me what is the y-axis of this graph telling us? Is it telling us velocity? Is it telling us displacement? Is what it's telling us? It's not the answer, but I'm just asking
Height?
what the y-axis of this graph is telling us.
The height?
The height.
Is it telling us displacement? velocity, acceleration, what it's telling us.
Sir, hello? Can you hear us?
What we have on the y-axis, can you hear me?
Yes, we
Yes.
can hear you. Can you hear us? Hello?
Can you hear me now?
Yes, sir, we can
Okay.
hear you. Can you
Okay,
hear us?
now I can hear you. So I was saying, what is on the y-axis?
The height.
The height, which is actually the displacement. So what will be the gradient of this graph? What will be the gradient of this graph? If you have on the y-axis height, which is actually a displacement, and on the x-axis you have the time. So what's the gradient of a displacement versus time graph? What gradient will tell you? Any problem with that? We need to know three things: displacement time graph, gradient gives us what happened. Can you answer this? Can you hear me? Can you hear me?
Yes, now we can hear you.
Okay, so what displacement time graph gradient gives us?
The acceleration.
Okay, there's displacement time graph gradient give us the speed or velocity. Velocity time graph gradient gives us the acceleration. Is that right? And area of velocity time graph give us the velocity time graph area give us the distance or displacement. Is that right? So for this graph, the gradient will tell you the velocity. So as you drop an object, should height increase or decrease? As we drop an object, what should happen to the height?
Decrease.
So if there is any graph where the y-axis is increasing, that cannot be the answer. Is right? So what it is? It means D cannot be the answer. Why? Because in all other three graphs, height is decreasing, but the last D graph, height is increasing. So these can be the possible answers, but not the last one. Got it? Is that right? Now the second part is gradient, which gives us the speed. So as you drop an object, as we drop an object, what happens to its speed? Its speed increases, decreases, or stays constant as we drop an object. Can you hear me? Oh, as you drop an object, do object fall with the constant speed? Like you drop from a low height, from a higher height, from a higher height. What happened? Will not the speed, as you drop an object, things don't float downward, things speed up. Speed increases. They accelerate downward. That's what we call acceleration due to gravity. Is that right?
Yes.
So they speed up. If they speed up, which part of the graph is giving you the speed? The gradient. So in which graph the gradient is increasing? We have discussed it in detail last time. So in which part gradient is increasing? Gradient is actually the steepness, not the y-axis. Gradient is the steepness. So in which part it's becoming more and more steeper?
B.
That's the right answer. Got it? So B is the one which satisfies both answers. As we drop an object, its height decreases, and as we drop an object, its speed increases. Got it? So we have to apply what I have practiced with you last time, that gradient, check out gradient and the y-axis separately. Got it? So that's good. So move to the next point, this one. Okay, I'll leave this one because you have to draw something on the graph. Practice question 4. Okay, so uh, okay, so a football dropped from the top of a 3-story building. It falls through air until it reaches the ground. What remain constant throughout the fall? We just have discussed velocity of the ball, football. Okay, 3-story building. Okay, that's right. Air resistance on the football, weight of the football. Okay, they are talking about air resistance. When there is air resistance, acceleration will not be constant, right? When there is air resistance, things slows down. They don't accelerate. Okay, it's the weight of the football. Got it, Fatma? Because acceleration due to gravity or the acceleration of the object is constant if there is no air friction. Is it clear? So as there is air friction, so its acceleration will reduce and eventually it reaches a terminal speed. So when it reaches the terminal speed, acceleration drop to 0. Got it? So earlier when we drop it,
But
it was, yeah.
But weight is mass into gravity,
Yes.
so neither mass nor gravity on the football will change. So why is
Yeah.
weight not constant?
So that's the answer. I said weight is the right answer. I just mentioned this for a different thing. Weight D is the right option. I said air resistance is changing. That's why this cannot be the answer. Got it? So answer is weight of the ball. Acceleration. Okay, you are thinking of two different things. There is a thing which is acceleration due to gravity. That's not going to get changed. Acceleration due to gravity will not change, but acceleration of the object will change. If you are getting confused with that. So acceleration due to gravity is constant. That is not going to get changed. But that option is not acceleration due to gravity. That was acceleration of the object. Acceleration of the falling object may change if there's air friction. Got it?
Yes.
So it was the acceleration of the object which is changing, not acceleration due to gravity which is changing. Skip this part. Okay, I have not discussed this concept. There are a few concepts which I have not yet discussed, so I do need to discuss it, but I want to discuss it like in the I just want to practice some question where they have actually work out like a graph or the equation of motion. So try to answer this one, question 13. Tanya, what's the answer to this question? Then I will discuss. Fatma, you need to reconsider your answer, but it's okay if you have Tanya, what's your answer? Okay. So both of you need to reconsider your answer. I will discuss why. Just give me a second. Again, the same concept must be used. Again, the same concept must be used. What is that? What y-axis gives us and what gradient gives us. So when we look at the y-axis is the distance fallen. So as we drop the object, the fallen distance will increase, which is in all cases the graph is going up, the graph is going up, the graph is going up, the graph is going up. But what will be the gradient of the graph? In this case, it's a distance time graph or displacement time graph. So what is the gradient? What is the gradient? We have earlier discussed. What's the gradient of this object, this graph? The gradient of this graph is what displacement distance time graph gradient gives us?
Acceleration.
Oh, why are you making mistakes with the same thing? This is the thing which we have written here. Try to recall it. Or distance time graph, if you have confusions, you can I'll let you know how to remove it. So distance time graph gradient actually gives us the speed. How to know that? Always gradient is change in y over change in x. Gradient is change in y over change in x. So when you write for distance and time, the change in y is the change in distance. Just what I want. The change in y is the change in distance, and the change in x is the change in time. So is it the formula for acceleration or velocity? Is the formula for velocity. And when we talk about velocity time graph, the gradient is change in y over change in x. So change in y is the velocity, and the change in x is the time, right? Which is the formula for acceleration. Got it? So the y-axis, the gradient of this question will give you acceleration. Oh, sorry, velocity. This one, displacement over time, gives you the velocity. So as you drop an object, what should happen to the velocity? Should it increase? Should it decrease? Or what? What will happen to the velocity? Not getting your answers. What as we drop an object, it's a simple thing. As we drop an object, what happens to velocity? The velocity will increase. That's right. So look at the graph cases where the gradient is increasing. In which graph the gradient is increasing? It's A and C. Got it? In A and C, the velocity is increasing, but they have mentioned a tennis ball falls freely in air from the top of a building. Okay. So as it drops from a top of a building, there are two things: dropped, or a tennis ball falls freely. So we are not throwing it, it falling freely. So if it's falling freely, what should be the initial speed? 0 or some value? We are not throwing it, we are letting it fall freely. What should be the initial speed then? Will it have some initial speed, or will the initial speed be 0 as we drop it? We are not throwing it, we are dropping it. So what will be initial speed? Uh-oh, your replying is not. If you have problems, you can still say that we have a problem, but don't stay quiet or irresponsive. Can you hear me? Just at least reply that so I can get. Can you hear me?
Yes.
Okay. So as we drop an object, we are not throwing it. Tanya, I need your reply, whether you know it or not.
Zero.
Unmute. Yes. Okay. So as we drop an object,
When
initial speed will be 0 or will have some value?
it'll be 0.
It's 0. So if initial speed is 0, what should be the gradient? In the start, initial gradient must be 0. Which graph has an initial gradient of 0? Not y-axis. All y-axis are 0. I'm asking gradient. Only one graph has a 0 gradient. All graph has y0, but only one graph has a 0 gradient. Which graph it is? Which has a 0 gradient in the beginning? Which graph is almost a horizontal line in the start?
A.
Horizontal line. A is the right answer. Look at this. This is some inclined line, is right? This D is clearly an inclined line. But this looks like, but not, still it is somewhat inclined. Got it? But look at this part. Isn't it horizontal in the beginning? Got it?
Yes.
So it start dropping from, and then why it's like constant. Look at it. It become constant. So when it moves with a terminal speed, the gradient become constant. So there are two problems with the graph C. No doubt its distance is increasing, its gradient is increasing, but one, it says it keeps on speeding up, which is not possible. Or eventually the object will reach the terminal speed at which it will move with a constant speed. So gradient will become constant. After increasing some speed, it become constant. Got it?
Yes.
So apply these kind of things. Okay, that's good. Uh, just a moment, skip this part. Okay, do this one, or okay, I will ask you to do this one later. Just read on. Okay, try to answer this one, question 17. That's right, Fatma. Tanya waiting for your answer. We just discussed that in the previous. Is the graph gradient horizontal at the start? Is the graph horizontal at the start? The gradient gives you the speed. For speed to be zero starts from rest. It starts from 0 meter, but not at rest. Because if it is at rest, the gradient must be zero. The graph must go like this in the beginning. Is it like this? This is speed zero, gradient zero. Got your mistake, Tanya?
Yes.
So it's not starting from zero. It's just simple speed changes. Initially gradient was less, later gradient was more. Got it? So simply the speed changes. Try to answer this one. Be careful. In this case, it's the acceleration on the y-axis. If acceleration, okay, Tanya, what's your answer for question 18? Tanya, waiting for your answer so I can discuss it. Your answer is right. Fatma, it's not B. Because are you familiar with terminal speed? If there is air friction, air resistance is not negligible. The object will reach finally a terminal speed. Are you familiar with that?
Yes.
So when object is falling with terminal speed, what will be the acceleration? Will it be accelerating or will it be moving with a constant speed?
Constant speed.
So it moving with a constant speed means acceleration will be 0. This graph is not reaching 0. Got it? This graph is trying to reach 0. Is it clear?
Yes.
So D is the right option. I will practice this one later. Okay, just one. Oh, it's the same question which we just practiced. Question number 25. Okay, so that's right. Okay, I will discuss that question later. Question 26, A127. Okay, even not this one, just a moment. I'm just practicing those questions which actually allows you to practice question number 29.
Sir, it was 20. Okay.
It has, although it's similar to the above one, but it has nothing to do with the above. Okay. Question 29. It just says that tube is a length. So drop from the top of the tube in a vacuum tube, it drops to the bottom in that much time. Find the length of that tube. It's actually an equation of motion question. I do tell you, write the data carefully, what things you have, what you have to find, and what's being not discussed in the question. Then check.
Sir,
Yes,
don't we need to know the speed?
we don't. That's what it is. This is a dropped, right?
Yes.
Okay, so as we drop the like the object, what will be the initial speed? Initial speed, as in all such cases, is 0, right? From rest. Can you see that? Can you see it? From rest. What does it mean? Initial speed is 0. Is that right? Can you hear me?
Yes.
Okay, use the initial speed 0. Acceleration due to gravity is 10 or 9.8. You can use whatever you like. You can use both for the moment because the answers are quite wide. So you have initial speed, you have acceleration, you have the time, you have to find the distance. So time is 0.5. Acceleration we know due to gravity, which is 9.8, or you can use 10. It's your choice. And we have to find the distance. So first tell me, in this question, in this data, which variable is not discussed? Which one is not discussed? Neither asked nor given. Which variable out of SUVAT, SUVAT, is not discussed in this question?
V.
That's right. It is V, which is not discussed. So just go to that equation sheet page and check which equation do not have V in it. Oh, that's not on this page. Just don't. I just open it. So do you know which equation do not have V in it?
The second one.
Yes. Okay, I'll check which one I have actually named second. The one which do not have V in it. Okay. So for me, the one I have, the second do have V in it. Just I show you. This is the set of equation which I have written here. Which equation do not have V in it? your responses are quite slow. The other group has 6 students, and all of them respond quite promptly.
The
I'm
third equation.
The third equation is the right one. S is equal to ut plus half at square. So use this equation. That's the trick to check which equation to be used. So you will use this equation for this data. S is equal to ut plus half at square. Check out what answer you get. That's the right answer, Fatma. Waiting for your answer, Tanya. Tanya, is there any problem in solving the question?
I'm not getting the correct answer.
It must be rounded off to 1 decimal point. What answer you got? Write your answer which you have worked out, or just say the answer. It's not 12. It shouldn't be 12. Okay, have a look. S is equal to ut 0 times 0.5 plus half at square. So half is 0.5, acceleration is 9.8, and t square is 0.5 square. So the answer is just 0.5 into 9. So do it on calculator once again. 0.5 into 9.8 into 0.5 square, and check what you get.
Now I'm getting A.
A is the right answer. That's good. Okay, try question number 30. You work it out. I will be back in 1 minute, please. No answer yet? It will be much easier if you try to answer this question in a reverse manner. This part, the first part, is an accelerated part. Got it? This is positive acceleration. Got it? So velocity increases. That's very good, Tanya. That's right. That's a really good answer. Waiting for your, that's good, very good. Waiting for your answer, Fatma. Okay, no, Fatma, it's not A. Have a look. You must practice it in 3 parts. In the first part, what's happened to the speed? Velocity is increasing, right? So velocity displacement time graph gradient is increasing. Which graph has an increasing gradient? This one do not have an increasing gradient, the first part, and this one is also a constant gradient. Y is increasing, but gradient is not. So A has an increasing gradient, that's right. But after that, what you think? The velocity decreases or stays constant?
Constant.
Constant. So look at that point. If you look at that dot thing, isn't the graph much steeper before it and less steeper after it? Isn't it? The gradient is becoming less. Is that clear? Its gradient is decreasing. But look at this one. It's increasing and then it's constant. And at the end, the gradient gradually decreases. Gradient in this case is still increasing. Look at this gradient. Oh, but it's a very steep gradient. Got it? So this means a negative gradient. This means a negative gradient. Is velocity negative at any instant? Is velocity negative at any instant? Fatma, is it negative at any instant?
No.
No. So that cannot be the answer. So the answer is C. Because in first, its gradient is increasing. Then its gradient is constant. Then gradient stays positive but decreases to 0. Got it? So you have to apply the concept of the gradient and the y-axis step by step. Okay, so not to do this one, I will just mention. Work out question 38. Write the data, then work it out. Okay, write it carefully and then check which variable is given, which is not given, which you have to find, and which is not discussed at all. There will be one such variable, and then you can pick the equation from here. I just share the equation screen. You can take a screenshot of those equations. So just wait a moment. So these are the equations. You can take a screenshot for that equation. Got? Have you done it? Screenshot?
Yes.
Okay, so
Yes.
question is here. So that's the question. Check what variables are given, write them with their symbols, and check which one is not discussed. Use that equation and find your answer. I will be like waiting for your answers, okay? So have you worked out your answers? Okay, I check the answer in a moment. You do it. Waiting for your answer, Tanya. Okay, just a moment, please. Okay, I'm just checking at a moment. I need to work it out. So it was the Fatma, earlier your answer was right. It was D. How you have to write your data? I again say that it's all the questions are done with the same way. So you can see that what it is. It says that initial speed is 50 meter per second. Maximum speed is okay, 10 meter per second traveling to the far. Okay, the comma. Okay, 50 meter per second. Question is actually starting from here. The above is like information. So initial speed is 50 meter per second. Driver applies the brake so that train decelerate to pass the marker, and at no more than 10 meter per second, the train carriers detector that notes the time when the train passes each mark and will apply an emergency brake if the time between 1 and 2 is less than 20 second. T is 20 second or less than 20 second. How far the two marks should be? uh, Mark 2 should be marker 1 be placed. How far marker 1 be placed from marker 2? So actually you need to find the distance, right? So final velocity is 10. Got it? And what you need to
Yes.
find? You need to find the distance. So which variable is not discussed?
Acceleration.
Use an equation without expression, which is v square is equal to u square plus 2as. So rearrange it for s because we have to find it s. So when you rearrange it for s, it is v square minus u square over, oh, what I'm doing. It has a in it. The one which do not have a is s is equal to v plus u over 2 times the t. So just put the values. So 10 plus 50 over 2 times 20. So what you get? 600. Is that right? This thing, actually I'm practicing these questions for this part. This thing is exact same step. Write the data, check which variable is given, which you need to find, and which is not discussed. Just use that equation and solve it. Is that clear now, Tanya?
I don't understand the point of the markers and
Okay, actually there are two things. One is understanding the statement, that's right. Even if you don't understand the statement, still this thing helps. Can you write these variables from the question? Again, I do just say, do you know, if I ask you, is the question discussing anything about the initial velocity? Leave the marker 1 and
Yes.
marker 2. So just write that.
Initial velocity is 50 meters per second.
And is it talking about any final velocity?
10 meters per second.
That's right. Is it talking about any time?
20 seconds.
Is it what it is asking us to find or prove? The distance between the two markers? How
Yes.
far is actually another word for the distance. Which one is not discussed? Acceleration? Use an equation without acceleration, you will get your answer. Irrespective what the question is saying. Got it? But by the way, what the question is saying, the question is saying that a train is traveling at a speed of 50, and there is a point after which the train should slows down, and there is a point after which the train speed must be less than 10. Okay, so the point, the marker 2 is actually an indication. You get an indication, okay, you need to slow down. And marker 1 is the final position that you should not cross it with a speed higher than 10. So you apply the brakes. When you apply the brake, your speed reduces for 20 seconds. So they said that the train reaches from marker 1, marker 2 to marker 1 in 20 seconds. So at least how much should be the distance in that 20 second the train has covered as its speed reduces from 50 to 10. Got it? But actually the other thing is much better. Try to focus on that data. You write your data, you can easily solve the question. Got it? Because the trick is the same. Write the variables given and to find, check which one is not discussed, and that's how it works. Okay. Is that fine?
Yes.
Okay, that's good. Fatma, your first answer was right, but later on you just switch it, but which was a little problematic. I just try to find a similar question. Try to practice this question number 45. It's exactly the same kind of thing. If you want to convert your speed, you can convert it in meter per second, but I think in this question you can like do it without converting. Okay, this is actually a much simple. You don't need to use even the equation of motion, because they are not talking about equation of motion. They are just talking about a simple thing. This question is a little tricky because you need to actually work out the total distance and the total time. So you call the distance as any distance s. This is the speed. So what is the time? time s is equal to vt. So t is equal to s over v, right? So the time for forward is right, like outward and return. So time is equal to, first one is s over 600. That's t1. What's the t2? That is s over 400. Is that right or not? Because we use just the formula s is equal to vt. So t is equal to s over v. Is that fine? So the time for the first flight was this much. Time for the second flight was this much. We assume the distance while forward and backward both was s. We don't have the s, but that's a different thing. But that distance is s. Is that okay? So what will be the total time taken? The sum of t1 and t2. Is that right? That's the total time. And what's the total distance? S distance forward and s distance backward. So the total distance is actually 2s. Got that point? Uh-oh. You two get like a minute.
Sir, can you explain the distance part again?
They said that same distance forward and backward. So if we have said that forward distance is s, will not the backward distance is also s?
Yes.
So we have worked out while going forward, it covers this distance s in time t1, and while returning back, it covers this same distance in t2. So this is also s. So what's the total distance it has traveled? 2s. And what's the total time it has taken? t1 plus t2. Is that right? So that's what we need to find the average speed, because average speed is total distance over total time. Is right. So I write the values. So the total distance we have is actually 2s, and t1 was s over 600, t2 was s over 400. So you add these two things, so you will get the total time. So s over 600 plus s over 400. That's the total time, and that's the total distance. Just use these two values to check what answer you get. Can you do that? Because average speed is total distance over total time. Okay, so try to work it out. LCM will be 1200. So this will be 2s plus 3s. So total time is 5s over 1200. That's the total time. So use 2s and like that. So what you will get, 2s over 5s into 12 divided by 1200. So what happened? S get cancelled and you solve the rest. What you get? Fatma, that's right. Tanya, what you get? That's right, Tanya. Very good. So practice question 47. Do not forget to convert kilometers into meters. 1 kilometer is 1,000 meters. Okay, Fatma, you have given the answer. Tanya, waiting for your answer. Fatma, your answer is right. Very good for that. So, Fatma, now you feeling confident how to use those equation of motion to solve such data questions?
Yes.
Okay, Tanya, are you have you noticed the distance is 1,000? Tanya? Okay, that's right. It is B. So that's what we need to do. Okay. So you can use all the unit in kilometers and hours and even the time in hours to solve question 48 the same way. Do not convert it because they all are in kilometers, kilometers, kilometers. It's your choice how you do it. But can you try to solve this thing? Question 48. So, okay, I do it for like, it's better to draw the picture to understand what's happening here. So the total distance is 200 kilometers, right? So the first 90 kilometer from 0 to 90 is covered with a speed of 80 kilometer per hour. So can you check how long it will take to cover that 90 kilometer? In hours, it is traveling with 80 kilometers per hour. Speed is 80 kilometer. And the distance is 90 kilometers. So in hours, how much time it will take? Simple. There is no equation of motion, but simple. How much time it will take? That's right, 1.1 hours. So that time is that right, Tanya? Just S is equal to VT, V over, VT. So T is equal to S over V. So you get 1.1 hour. So to make the whole journey in 2 hours, how much time should it take for the next half of the journey? 0.9 hours. But how much is the distance? 80 kilometer out of 200 it has traveled. So the rest distance is 120 kilometers. So it covers 120 kilometer in 0.9 hour. So what will be the speed? Speed will be equal to distance over time. So can you check out what's the next speed? (120) in 0.9 hours.
Sir, won't the rest of the distance be 110 kilometers?
Oh, my mistake. Yeah, that's right. Sorry for that. I overlooked it. You are right. It's 110. because the distance was 90. So my mistake. Yeah, 110 over 0.9, what you get? $122, which is the C option. Got it? Tanya, is that clear? I may have to work on your all of like both of your communication skills. Your communications are a bit slow. Tanya, can you hear me?
Yes.
Is that clear?
Yes.
Okay, so that's it for today. Any question from what we have practiced today?
No.
So thank you. Have a nice day. Allah Hafiz.
Allah Hafiz.
I love it.
Allah Hafiz.